Imagine a photograph that's eerie enough to send chills down your spine every time you look at it. Now hold that thought. We're traveling back in time to the year 1966 during the Gemini 12 mission. This was an integral part of NASA's journey towards the moon landing, but it also gave us one of the most haunting images in the history of space exploration. The photograph in question features astronaut Buzz Aldrin, the second man to walk on the moon. Yet this image was captured 3 years before that historic lunar footprint. In this photograph, Buzz Aldrin, clad in his astronaut suit, appears faceless. His visor, a polished surface mirroring the infinite black void of space. It's as if the universe itself is staring back at us, a terrifying reminder of the vast and unknown nature of space. This image is often referred to as the scariest astronaut picture, and it's not difficult to understand why. The stark contrast between the astronaut, a symbol of human achievement and curiosity, and the dark, endless expanse reflected in his visor is unsettling. It encapsulates the extreme isolation that astronauts must feel when they're out there surrounded by nothing but the silent, empty void. But it's more than just a feeling of isolation. This image also speaks to the great unknown that is space. Even with all our advancements in technology and space exploration, there's so much that remains a mystery. It's a reminder that we are but small, insignificant beings in the grand scheme of the cosmos. The image, as terrifying as it may be, also holds a certain beauty. It's a testament to human courage and our insatiable desire to explore and understand the world beyond our own. Despite the fear, despite the unknown, we continue to reach for the stars, to push the boundaries of what we know and where we've been. So, in a single frame, this photograph encapsulates the immense void and the chilling isolation that is space. It forces us to confront our fears, our insignificance, and our curiosity. It is a symbol of the eerie beauty and the terrifying unknown that is the universe. It truly is the scariest astronaut picture. Space, as it turns out, has no air to carry sound. This might sound strange, but let's delve into the science behind it. Sound as we know it on Earth is essentially the vibration of atoms and molecules. These vibrations create waves in mediums such as air or water, and these waves travel to our ears, allowing us to hear. Now imagine a place where there's no air, no water, no molecules to vibrate. That place is space. Devoid of any medium for sound to travel through, space is a realm of eerie silence. A shout, a song, even the loudest explosion would not make a sound. It's a concept that's difficult to grasp, especially when we're so used to sound accompanying every action in our lives. So if you ever find yourself out there, don't expect to hear anything, not a sound. The dark side of the moon isn't always dark. Now that might sound a bit contradictory, but bear with me. You see, the moon performs a delicate dance with Earth, rotating on its axis at the exact same rate that it orbits our planet. This cosmic ballet is known as synchronous rotation. What does this mean for us Earthlings? Well, it ensures that we always see the same face of the moon, creating the illusion of a dark side that never sees the light of day. But here's where it gets interesting. This so-called dark side is not shrouded in perpetual darkness as the name might suggest. In fact, it receives its fair share of sunlight. It's only dark in the sense that it's hidden from our view, cloaked in mystery and sparking our curiosity and wonder. So the dark side is really more about mystery than actual darkness. Time works differently on Venus, where a day lasts longer than a year. Now, that might sound a bit strange, but let's dive into it. You see, Venus has an extremely slow rotation on its axis. How slow, you ask? Well, it takes a whopping 243 Earth days for this planet to complete a full rotation. That's right, a full day-night cycle on Venus is longer than 7 months on Earth. But here's where things get even more interesting. Despite its sluggish spin, Venus whips around the Sun at a much quicker pace. It completes an orbit in just 225 Earth days. Yes, you heard it right. A year on Venus, the time it takes to journey around the Sun, is shorter than a Venusian day. This celestial conundrum is one of the many wonders that make space exploration so fascinating. So, if you're ever feeling like there aren't enough hours in the day, maybe a trip to Venus is in order. Space isn't as clean as you might think. It's actually filled with junk. Now, when we say junk, we're not talking about candy wrappers or old soda cans. We're talking about defunct satellites, spent rocket stages, and fragments from disintegration and collision. This is what we refer to as space debris, or more colloquially, space junk. This isn't just a handful of items either. Imagine the countless missions, explorations, and experiments that have taken place since the dawn of the space age. Each one of these has left behind some trace, some piece of equipment or fragment that now orbits our planet. Picture this as a kind of cosmic dust cloud. an invisible shroud of technological remnants that circles the Earth. But why is this a problem? Well, consider this. Even a tiny piece of debris, when moving at high speeds, can cause a considerable amount of damage. This is known as the Kessler syndrome, a scenario where the density of objects in low Earth orbit is high enough that collisions could cause a cascade, each collision generating space debris that increases the likelihood of further collisions. This poses a significant risk to both manned and unmanned space missions. It's like navigating a minefield, except the mines are moving at thousands of miles per hour and can come from any direction. The International Space Station, for instance, has had to perform collision avoidance maneuvers on numerous occasions to dodge this space junk. And it's not just about avoiding accidents. This clutter also poses a challenge for future space exploration and satellite deployment. It's a bit like trying to find a parking spot in a lot that's already full. So, even in the vastness of space, we've managed to create a clutter problem. It's a stark reminder of the impact we have on our surroundings, even when those surroundings are as immense and seemingly untouched as outer space. Living in space can make you taller, but it's not as fun as it sounds. This is because the microgravity environment of space affects astronauts in ways we might not initially consider. One of these effects is on the spine. Without the constant pull of Earth's gravity, the vertebrae in an astronaut's spine can expand, making them up to 2 inches taller. Imagine waking up one morning and finding out you've grown overnight. But before you start thinking how cool it would be to gain a few extra inches, consider this. It's not without complications. This sudden growth spurt can lead to back pain. And when astronauts return to the gravity of Earth, the spine contracts again, which can cause even more discomfort. Plus, the adjustment to Earth's gravity after being in space can lead to other health issues like muscle weakness and reduced bone density. So, while growing taller might sound fun, in space, it comes with a price. Black holes, despite their name, aren't actually black. Now, this may seem contradictory, but let's delve a little deeper into this cosmic conundrum. Picture a black hole, a region in space where gravity is so strong that nothing, not even light, can escape its grasp. This is why we've always imagined black holes as these vast, dark, all-consuming voids. But let's take a moment to consider the man who brought us the concept of black holes, Albert Einstein. According to his theory of general relativity, black holes form when a massive star collapses under its own gravity. This collapse results in a dense point known as a singularity, surrounded by an event horizon, the point of no return for anything that gets too close. Now here's where things get interesting. If the gravity of a black hole is so intense it can pull in light, then, logically, it should appear black, right? Well, not quite. The late physicist Stephen Hawking proposed a theory that black holes might actually emit a type of radiation, now known as Hawking radiation. Hawking suggested that quantum effects near the event horizon could produce pairs of particles and antiparticles, one of which may fall into the black hole while the other escapes. This escapee particle results in the emission of radiation from the black hole. Therefore, if Hawking's theory holds true, black holes might not be entirely black after all. They might be very, very faintly glowing due to this emission of radiation. Of course, detecting this faint glow is another challenge altogether, but that's a story for another day. For now, let's marvel at the thought that even black holes, the universe's ultimate light traps, might not be as black as we once thought. So even the most frightening entities in space might not be quite as they seem.